Hello friends. Picture a volcano. A colossal force of nature, dormant for centuries, that suddenly awakens with a power that defies imagination. But this volcano doesn't spew lava. It erupts with pure, focused energy. And it doesn't just sculpt a single mountain or island. It carves an entire galaxy. Now, what if I told you that this cosmic volcano is a black hole? For decades, we've seen black holes as the universe's ultimate dead ends, silent, inescapable monsters that devour everything that strays too close. They were the end of the story, a cosmic tomb from which nothing, not even light, could return. The dark, consuming black hole suddenly erupts with brilliant jets, transforming from destroyer to creator, with energy streams reshaping surrounding space. But what if that story is profoundly incomplete? What if the most destructive force in the cosmos is also its most powerful creator? We are discovering that black holes don't just swallow worlds, they erupt. Zoom out from a single galaxy to reveal the massive Porphyrion jet structure spanning 23 million light-years, with multiple galaxies for scale comparison. They unleash cataclysmic blasts of energy that reshape the cosmos, and recently, astronomers found the largest of these eruptions ever seen, a structure so vast it almost defies belief. Dynamic sequence showing jets triggering star formation, clearing gas clouds, and sculpting galactic structures in a violent dance of creation and destruction. Forget the silent vacuum cleaners of old science fiction. The real story of the universe is not one of quiet endings, but of violent, creative rebirth. Majestic wide shot of multiple black holes across the cosmos, each with jets, resembling a cosmic forge with anvils of creation scattered throughout space. It's time to meet the cosmic volcanoes that forge the heavens. First, let's revisit what we thought we knew, because the classic picture of a black hole is still terrifyingly true, and it sets the stage for the paradox to come. A black hole is born from the fiery death of a truly massive star. Cross-section view of a massive star, showing the delicate balance between inward gravitational forces and outward fusion pressure, with the balance suddenly breaking. When a star many times larger than our Sun exhausts its nuclear fuel, the delicate balance it maintained for millions of years, a cosmic stalemate between gravity pulling in and fusion pushing out, is broken. The outward push of fusion, the engine that held gravity at bay, abruptly ceases. In that one, final instant, gravity, the universe's most patient and relentless force, wins its final, brutal victory. The star's core collapses catastrophically under its own immense weight, crushing down past every known limit of matter. Protons and electrons are squeezed together into a sea of neutrons, and then even that state is overwhelmed, collapsing into a point of density so extreme our physics can no longer describe it. A singularity. This collapse is so violent, it triggers a supernova, a final, glorious explosion that for a brief time can outshine an entire galaxy. This cosmic death cry flings the star's outer layers across space in an expanding, beautiful nebula, seeding the cosmos with the heavy elements, the iron in your blood, the calcium in your bones, that make future planets and life possible. But what's left behind is the monster. It is a region of space-time so warped that nothing, not even the fastest thing in the universe, light, can escape. This region is enclosed by a boundary called the event horizon. This isn't a physical surface you could touch, see, or bounce a signal off of. It's something far more profound. It is a one-way door in the universe. Imagine space-time as a river flowing towards a waterfall. The event horizon is the point where the river's current becomes faster than the fastest boat you could possibly build. Once you cross that point, no matter how hard you paddle, the current will carry you over the edge. To escape from inside the event horizon, you would have to travel faster than the speed of light, which is fundamentally impossible. Cross this threshold, and you are removed from the observable universe forever. The picture is one of simple, cosmic horror. Matter that drifts too close, an unlucky gas cloud, a wandering star, is ensnared in a gravitational death spiral. As it gets closer, The immense gradient of gravity across the object stretches it vertically and squeezes it horizontally, in a process grimly and aptly known as spaghettification. The star is unraveled into a long, thin stream of superheated plasma. The stellar material emits brilliant X-rays and light as it's whipped around the black hole in its final moments before disappearing beyond the event horizon. It's not an instantaneous death, but a slow, agonizing unraveling as tidal forces tear it apart, atom by atom. This stellar noodle then lets out one last brilliant scream of X-rays and light as it's whipped around the black hole before being swallowed into the abyss. Its light, its matter, its very information are seemingly locked away from the cosmos for eternity. Hold on to that thought about information, by the way. It becomes one of the deepest and most troubling mysteries in all of physics. For the longest time, this was the whole story. Black holes were passive, gluttonous cul-de-sacs where our physics breaks down and matter goes to die. They were the universe's final punctuation mark. But as our most advanced telescopes peered deeper into the violent hearts of distant galaxies, a paradox emerged that refused to be ignored. These regions were supposed to be the darkest places in the cosmos, yet they were often the brightest. Something was fundamentally wrong with this picture. Something colossal was coming out. Imagine you're an astronomer looking at the heart of the galaxy Messier 87, about 55 million light-years away. This is the home of M87, a supermassive beast 6.5 billion times the mass of our Sun, and the very first black hole we ever photographed directly. Recreation of the iconic Event Horizon Telescope image showing the black hole's shadow against the bright orange accretion disk, emphasizing this historic achievement. That iconic, world-changing image, captured by a planet-sized network of telescopes called the Event Horizon Telescope, wasn't the black hole itself. That's impossible to see. What we saw was its shadow, its silhouette, cast against a fiery orange ring of glowing matter on its final, desperate plunge to oblivion. Detailed view of the accretion disk as a violent, chaotic whirlpool where matter is accelerated to relativistic speeds, heating to billions of degrees. That ring is part of a vast, swirling vortex of star stuff called the accretion disk. But this is no quiet river flowing into a dark ocean. It is a chaotic, nightmarish whirlpool where friction, gravity, and magnetism collide in a symphony of destruction. Matter in the accretion disk, glowing white-hot as it's compressed and heated, showing temperature comparisons with our Sun's core. Matter trapped in this disk is accelerated to a significant fraction of the speed of light, compressing and heating it to billions of degrees, hotter than the core of our Sun. This disk is a cosmic meat grinder, and its sheer violence makes the immediate vicinity of the black hole one of the most luminous and energetic places in the entire universe. Close-up of chaotic feeding process, with matter swirling violently around the black hole, emphasizing the messy, turbulent nature. It's a very, very messy eater. But then, our telescopes see it. And this is where the story changes forever. Blasting from the north and south poles of this feeding monster are two impossibly thin, brilliant beams of light and plasma. These aren't small leaks or minor flares. Follow the M87 jet as it travels at 99% light speed, stretching thousands of light-years through and beyond the galaxy. A glowing spear piercing space. They are colossal blowtorches fired into the void at nearly the speed of light. The jet erupting from M87, for example, travels at over 99% the speed of light and stretches for thousands of light-years. A glowing spear of energy piercing clear through its own galaxy and extending far out into intergalactic space. Scale comparison showing the tiny black hole versus the massive jet structure it creates, emphasizing the incredible size disparity. It's a structure vastly larger than the black hole that creates it, a testament to some unseen, incredible engine. And here's the paradox that baffled scientists for decades. How can an object defined by its perfect, inescapable gravity be the engine for the most powerful outflows in the universe? Nothing can escape from inside the event horizon. That is the absolute defining rule. So where is this material coming from? How is it being accelerated to such tremendous relativistic velocities? Long-distance view of jets, maintaining their tight focus across millions of light-years without dispersing, emphasizing the mystery of their stability. And just as puzzlingly, how is it focused into a beam so tight and stable that it can travel for millions of light-years without dispersing into nothing? A volcano erupting from the bottom of a whirlpool, illustrating the counterintuitive nature of the phenomenon. It's like watching a volcano erupt from the bottom of a whirlpool. It defies intuition. The laws of physics seem to be at war with themselves. On one hand, you have the ultimate gravitational sinkhole, and on the other, the universe's most powerful fountain. The black hole actively fighting back against space itself, launching jets as a counterattack, with space-time visibly distorting around it. The cosmic monster wasn't just passively feeding, it was actively fighting back, launching a counterattack against the very space it occupied. And the secret to its power wasn't hidden in the matter it was eating, but in an audacious act of cosmic theft from reality itself. The answer will force us to rethink the very fabric of space and time. The answer to this grand cosmic puzzle, it turns out, isn't inside the black hole. Instead, these cosmic cannons are born from a mind-bending partnership between the violent accretion disk, phenomenally powerful magnetic fields, and the black hole's own ferocious spin. This is where we truly get to see how black hole jets don't just pull matter in, they bend reality. It all starts with the spin. They grab the very fabric of the universe and drag it around with them. For a helpful, if imperfect, analogy, imagine a heavy, spinning bowling ball submerged in a vat of thick honey. Inside this region, it's impossible to stand still relative to a distant observer. You are forced to be dragged along with the black hole's rotation, whether you like it or not. Now, let's add the magnetic fields. These field lines get tangled and twisted by the chaotic motion of the infalling matter. This is where the magic happens, a process first mathematically described by physicists Roger Blanford and Roman Zanajek. This extreme twisting and spinning of the magnetic field transforms the rotating black hole into a colossal electric generator. One particle of the pair, with negative energy, falls into the black hole, while the other is accelerated away from the black hole's poles at nearly the speed of light. So, let's be crystal clear about this, because it's one of the most incredible ideas in physics. The energy for the jet isn't coming from the matter falling in. The magnetic fields act like a cosmic clutch, connecting the outward flying plasma to the black hole's spin. It's a reality-bending act of cosmic energy laundering, converting the black hole's angular momentum into the raw kinetic power of a jet. But how do these jets stay so perfectly straight and narrow for millions of light years? Recent observations suggest a complex, spine sheath structure. As the plasma is shot outwards, the helical fields confine the particles into a tight beam through a phenomenon known as the pinch effect. These magnetic fields are the universe's thumb, focusing a diffuse eruption into a cosmic blowtorch of terrifying power and precision. We've just bent the rules of reality to see how these cosmic volcanoes work, converting the spin of a black hole into the most powerful cannons in the universe. And if you believe that understanding our universe is a critical mission, that this knowledge is worth pursuing, then you're one of us. This channel exists because of viewers like you who are passionate about science. So if this blew your mind even a little, I want you to help hype this video. Seriously, hype it. Hit the like button, share it, and let the algorithm know that deep science deserves attention. And if you want these kinds of big, reality-bending deep dives to continue and grow, do us a huge favor and subscribe. It tells the algorithm that this is content worth seeing. Now, let's look at the chaos these jets unleash upon the universe. These jets aren't just local fireworks. They are one of the most influential forces in the cosmos, shaping the evolution of entire galaxies. This brings us to a new, central thesis of modern cosmology, that on the largest scales, these jets may shape galaxies more than gravity itself. The impressive M87 jet stretching across space, establishing it as the previous record holder for size. For a long time, the jet from M87 seemed impossibly huge. But in late 2024, a discovery was announced that forced us to completely redefine the word huge. This is the story of the largest black hole jet ever discovered. Using the LOFAR radio telescope array, a network of antennas spread across Europe, astronomers found a jet system so enormous it dwarfs all others. Nicknamed Porphyrion, after a giant from Greek mythology who rebelled against the gods, this structure emanates from a galaxy 7.5 billion light-years away. The twin jets of Porphyrion, stretching 23 million light-years across space, dwarfing all other known structures. The twin jets stretch for a combined total of 23 million light-years across space. Let's pause to absorb that scale. Our own Milky Way galaxy is about 100,000 light-years across. This means you could line up not 10, not 100, but 230 Milky Way galaxies end to end, and they still wouldn't span the full length of this one structure. Porphyrion, as a scar on the face of the cosmos, testament to the power of a single spinning black hole, active for 1 billion years. It is a scar on the face of the cosmos, a testament to the unbelievable power locked within a single spinning black hole, active for perhaps 1 billion years. Its discovery hints that these giant jets may have played a far larger role in shaping the early universe than we ever imagined. Because the universe was more compact 7.5 billion years ago, a structure like Porphyrion would have stretched across a much greater portion of the cosmic web. The vast, filamentary structure of gas and galaxies that forms the skeleton of the universe. It could have potentially seeded the vast voids of intergalactic space with the universe's first magnetic fields, influencing how and where later generations of galaxies would form. So what happens when one of these beams, carrying the power of 1 trillion suns, slams into a galaxy? Paradoxically, it brings both destruction and creation. It's a critical process scientists call black hole feedback. Jet plowing through diffuse gas and dust between stars, acting like a snowplow from hell, creating massive shock waves. As a jet plows through the diffuse gas and dust between stars, it acts like a snowplow from hell, creating immense shock waves that stretch for thousands of light years. Chandra X-ray Observatory, revealing glowing knots inside jets where plasma slams into gas clouds, heating gas to millions of degrees. Recent observations with telescopes like the Chandra X-ray Observatory have even revealed glowing knots inside these jets. These are points where the plasma slams into dense gas clouds or is violently accelerated in shocks. These shocks heat the gas to millions of degrees until it glows brightly in X-rays. Particles being boosted to highest energy cosmic rays through Fermi acceleration, turning the jet into a massive particle accelerator. This is also where particles can be boosted to become the universe's highest energy cosmic rays through a process known as Fermi acceleration, turning the jet into a massive particle accelerator. Young galaxy bustling with star formation, suddenly hit by awakening black hole jets, sterilizing stellar nurseries. Imagine a young galaxy, busy and bustling with activity, birthing new stars in its cool, dense clouds of gas. Then, the supermassive black hole at its center awakens and unleashes its jets. The beam sweeps through the galaxy like a sterilizing wind, flash heating the gas clouds that were once ripe for star formation. Star-forming regions being shut down by the passage of jets, with gas clouds dispersing and cooling. The stellar nurseries are shut down. In this sense, black holes are cosmic gardeners, pruning their host galaxies, preventing them from growing too large too quickly. Some simulations suggest this feedback process is responsible for stopping as much as half of all potential star formation across the cosmos. This creates a spectacular self-regulating loop on a galactic scale, a cosmic thermostat. When a galaxy pulls in too much cold gas, it fuels the black hole, which powers up the jets. The jets then erupt, heating and expelling the gas, which in turn cuts off the black hole's food supply. The complete cycle showing jets dying down, galaxy cooling, gas collecting again, and the cycle repeating over millions of years. The jets die down over millions of years, the galaxy cools, gas begins to collect again, and the cycle can repeat. For instance, we are just beginning to probe the intricate magnetic fields that are the backbone of these structures. This is where a new generation of instruments comes in, like NASA's XP. XP's Discovery mission, showing competing theories for X-ray production and the polarization measurements that act as a cosmic compass. Entropy's mission is a mini-arc of discovery in itself. For decades, we had competing theories for how jets produce high-energy X-rays. By measuring the polarization of this light, essentially the collective orientation of the light waves, Entropy can act like a cosmic compass, revealing the direction and structure of the magnetic fields at the source. Entropy's landmark 600-hour observation of the Perseus cluster, settling the 40-year-old debate about X-ray production mechanisms. In a landmark 600-hour-long observation of the Perseus cluster, Entropy settled a 40-year-old debate. It confirmed that the X-rays come from a process called inverse Compton scattering, where lower energy light is kicked up to higher energies by fast-moving electrons within the jet. This ruled out other exotic theories involving protons and proved the fundamental role of magnetic fields in powering these phenomena. Jets pointed directly at Earth, creating blazars, with light energized and brightened by relativistic Doppler boosting effects. Sometimes, by a pure quirk of cosmic alignment, these jets are pointed directly at us. We call these objects blazars, and their light is incredibly energized and brightened by relativistic effects like Doppler boosting. Chilling scenario of our galaxy's Sagittarius A firing up and pointing a jet toward Earth, contrasted with its current dormant state. One such blazar is harmless at its immense distance, but it raises a chilling question. What if a powerful jet from our own galaxy's supermassive black hole, Sagittarius A, fired up and pointed our way? Thankfully, our home giant is currently sleeping, but faint ghost jets detected by the Fermi Space Telescope suggest it was much more active in the past. Emphasis on the dynamic and sometimes threatening nature of our galactic neighborhood with past jet activity. This highlights the dynamic and sometimes threatening nature of our galactic neighborhood, and it's not just the supermassive black holes. Our galaxy is home to microquasars, where a small stellar mass black hole strips material from a companion star and launches its own miniature jets. These prove that the volcanic engine is a fundamental part of black hole physics, scalable from city-sized objects to those weighing billions of suns, all obeying the same core principles. Microquasars as perfect smaller-scale laboratories for studying accretion and jet physics in detail. They are perfect smaller-scale laboratories for studying accretion and jet physics. Two black holes orbiting each other, creating gravitational waves, with misaligned spins affecting jet behavior. What happens when two black holes orbit each other? We know they merge, creating gravitational waves. Recent studies show that when black holes in a binary pair have misaligned spins, their combined jet doesn't fire straight, wobbling or precessing jets like a dying spinning top, spraying particles across the galaxy like a cosmic sprinkler. It can wobble or precess like a dying spinning top. Instead of a steady beam, the jet becomes a wobbling cosmic cannon, spraying high-energy particles across its host galaxy like a giant sprinkler, dramatically increasing its impact zone and carving out huge cavities in the surrounding gas. Transition into more speculative and visionary scientific territory, pushing beyond current understanding. These discoveries are pushing us into even more speculative and visionary territory. We talked about black holes as galactic exhaust systems for angular momentum, but could they also be exporting entropy? The second law of thermodynamics demands that entropy, or disorder, must always increase. A black hole, by its nature, represents a state of immense entropy. Perhaps jets are the universe's way of balancing the books, ejecting a stream of highly ordered, low-entropy material in the form of the focus jet to compensate for the immense entropy locked inside the black hole itself. And what about that question of information? Remember how anything falling in is supposedly lost forever? This violates a core tenet of quantum mechanics called unitarity, which states that information can never truly be destroyed. This conflict is the information paradox. If you burn a book, you could, in principle, reconstruct the information from the smoke, ash, and heat. But a black hole, according to Hawking's original theory, radiates energy that contains no information about what fell in. Some radical new theories propose solutions. The holographic principle suggests information isn't inside the black hole at all, but is encoded on the two-dimensional surface of the event horizon, like a cosmic hologram. Quantum hair theory showing subtle imprints of fallen matter on the black hole's gravitational field that can be carried away. Other ideas, like quantum hair, propose that a star's quantum information leaves a subtle imprint on the black hole's gravitational field, which can then be carried away, allowing information to escape. Could jets, as they rip energy from space-time near the horizon, be interacting with this holographic plate, or reading this quantum hair, carrying faint echoes of what fell in long ago? We began with the simple, terrifying image of a black hole as a silent monster. We end with something far more profound, complex, and beautiful. Cosmic volcanoes, powered by space-time spin rather than magma, emphasizing the successful explanation of the phenomenon. We've delivered on our promise. This is black hole jets explained. They are cosmic volcanoes, powered not by magma, but by the raw spin of space-time itself. Jets as vital engines in the life of the cosmos, rather than mere endpoints, actively shaping galactic evolution. Black holes use jets to carve galaxies, regulate star formation, and write cosmic history. These jets, including record breakers like Porphyrion, stretching across millions of light years, are the tools it uses to carve galaxies, regulate star formation, and write cosmic history. This supports our bold claim. They are not just side effects. They are a fundamental force, arguably more influential in shaping the large-scale structure of the universe than gravity. New questions arising from each answer, showing the endless frontier of scientific discovery. With every answer, new, more fascinating questions arise. We see jets bend, but what bends them? Speculation about jets holding keys to understanding dark matter and dark energy through ultra-high energy phenomena. Could these ultra-high energy phenomena hold the key to understanding dark matter, or even dark energy? Future interstellar civilization using predictable blazar beams as cosmic lighthouses for galactic navigation. Looking 50 to 100 years into the future, could a mature interstellar civilization use the predictable, powerful beams of blazars as cosmic lighthouses for navigation across the galaxy? Speculative engineering of a Dyson sphere around a microquasar, harnessing jet energy to power an entire civilization. Could we construct a Dyson sphere, not around a star, but around a microquasar, harnessing the far more efficient energy output of its jets? Such an engine could power an entire civilization, but the engineering challenges would be monumental, requiring materials and technologies we can't even imagine. Black holes as complex, dynamic, fundamental characters in the story of everything, embodying cosmic beauty. The black hole is no longer a simple monster. It's a complex, dynamic, and fundamental character in the story of everything, a perfect embodiment of the violent, chaotic, and ultimately creative beauty of our universe. Inspiring final call to action encouraging viewers to share, engage, and continue the journey of cosmic discovery. Has this journey changed the way you see black holes? If you think this kind of science deserves to be seen, help us break the algorithm. I want you to hype this video. Yes, actually hype it. Share this video with one person whose mind you want to blow today, hit the like button, and let the algorithm know that curiosity matters. Subscription call with notification bell, emphasizing weekly deep cosmic mysteries and community engagement. Make sure you're subscribed with that notification bell on, because we explore deep cosmic mysteries like this every single week. What's your wildest theory about what we'll discover next with these cosmic jets? Let us know in the comments below. Final inspiring shot of the cosmos with jets stretching across the universe, ending with the call to stay curious. Stay curious.